In this video, we're going to look at the Randomized Experiment software assignment. So before we get started, I have RStudio opened, and you may have noticed in the previous video that my RStudio has a black background. The default background in RStudio is a white background, and so that may be what you have on your computer. Typically, I like to have a darker background because I think it helps with eye strain. So if this is something that you're interested in having and you prefer this type of color scheme, I'm going to show you how to change that really quick. This isn't something that you have to do. It's a purely cosmetic thing and it won't change the code at all. If you would like the darker background, to do that, click on Tools, then Global Options, and then you'll click on Appearance. Notice down here in Editor Theme, there are lots of different potential color types. And so you can click on any of these themes and find one that you like. Again, it's not going to change the functionality of R. It's not going to change how your code runs. It's purely cosmetic. And again, I like the darker background. The one that I use is called Chaos. Again, for eye strain is why I like that. You can also change the font size. So if you like to have your font a little bit larger, you can do that here. And then you just click OK, and it will change that for you. Alright, so let's look at this exercise. For this exercise, there are several files that you need to have from Canvas. You want to have the R file or the R script, which I have open here. There's also a data set. As well as the data set and the script, there's going to be the actual assignment, and then there are two supplementary files that describe the data set. So there's 5 files in total that you'll need to have downloaded from Canvas. So before we actually look at the coding portion, let's talk just a little bit about the data set. So there are 2 different PDFs you should have downloaded. One is an introduction to the data set, and the other one is what is called a data dictionary. Whenever you analyze data in the real world, you are never going to analyze data in a vacuum. The background information about the data is always incredibly important, and that's going to help you decide how to analyze data. So that's why in these first couple weeks of the course, you'll notice we're talking a lot about where does data come from. Because again, where data comes from, that's going to tell us the type of inference that we're able to make. So the first thing you'll want to do is make sure that you've read through about this data set. So you'll want to scan through this document, and you notice it'll give you an overview of the data set, and you'll find out that this data set does come from a randomized experiment. And then the other thing you'll want to look over is what's called the data dictionary. So data, when we enter it into a computer, especially when we look at what are called categorical variables. So for example, anesthetic group is a categorical variable. The groups either receive the mixture of the drug or sequential. Well, when this is put into the actual data set, it's rarely entered as mixture and sequential. It's usually entered as numbers that represent those words. And so a data dictionary will help you move from what the actual values are to the numbers that they are coded from. So usually there'll be a data dictionary, and that's something you're always going to want to have handy when you analyze data. All right. So next, let's look at the actual assignment and talk about what it is that we want to do with this code. So hopefully you've already read through this. If not, take a moment and read through it. And you'll notice in the assignment there are 2 different tables that you're going to fill in. So this is a randomized experiment where participants were randomly assigned to one of 2 groups, and which group they were in determined what type of anesthetic or whether they were getting the mixture or the sequential doses. And you'll notice in these tables I've got some number signs. So the goal of this assignment is we're going to run code, and you're going to fill in these number signs. Now, since these patients or subjects were randomly assigned to the 2 different groups, often what we're interested in are some demographic information about those groups, as well as outcomes from the 2 different groups. So that's why we have 2 different tables here, one for their demographic information and one for the post-operative opioid consumption. Now these 2 different tables, as far as analyzing the data, we're going to look at them separately. For the demographic information, since we have randomly assigned those patients to the 2 groups, one of the things that by randomly assigning them, we hope that the demographic information on average is going to be the same between the 2 groups. Now, since we make that assignment randomly, there's no guarantee, that we'll end up with the same percentage of males in both group or the same mean median age, but these are things that we want to look at to make sure there's no large difference between them. And if there is, we might want to, when we analyze the data, account for that difference. So having an initial look at the demographic information is very important. So here we're going to run code, and what we're going to do is for each of the groups, we'll find out how many people were in each groups. We'll look at the mean and median BMI, mean and median age, and then we'll look at the percent that are male. Now, the second table is the postoperative opioid consumption. This would be something we look at after the patients or the subjects have received the treatments, and so this is what we would call an outcome variable. And what we're going to do is we're going to see if the outcomes are different between the two groups. Now, later on in the course, what we'll find out is if these two numbers are different, for example, this particular opioid consumption, we need to use statistical methods to figure out if that difference is purely due to chance or if there actually is a significant difference. And so we'll learn how to do that later on in the course, but for right now, we're just learning how to summarize these outcome variables. And then there'll be some other questions that you'll answer too. All right. So again, if you haven't read the pre-information, make sure you do that before we start actually looking at the code. So if you need to, pause the video here. Otherwise, we'll go ahead and look at the code. All right, so I've got my script open. As always, I've just kind of got started up here with some comments. You want to fill in your name and your date. And then the next thing we're going to do is read in that data set. So here I've got the set working directory code to read in my data set. Now, if you're using the same folder for all of your assignments, this will be the same set working directory we used for the random sampling assignment. If not, let me show you how to find that. So over here in the bottom right-hand window, click on the Files tab, and you'll notice three little dots here. So you click on that, it will open up all of the files on your computer, and from here, you can navigate to where you have the files located on your computer. So I'm navigating to where they are on mine. Of course, they'll be in a different spot on your computer. So once you get down to that folder, you'll click OK. That folder will automatically open here, and so you'll see all the files that are in that folder. And then you can click on More, Set as Working Directory, and you'll notice that line of code auto-populates in the console, so you can always copy that and paste that up into your script. So the next thing we're going to do is read in the data. So you saw the read.csv file earlier. We're going to use that function again. So what I'm going to do is I'm going to call the read.csv function. In quotations, I'm going to give it the name of the file that's in that folder that we just set the working directory to be. And I want header equal true. The reason I want header equals true is this data set does have the variable names across the top row. If it did not have that, then I would not need this piece. And then I'm going to set that equal to superclavicular here so that this will now be the name of my data set. So if we run this, we'll notice my data set's populated. You always want to do a check of your data set. So here it tells me there's 103 observations of 17 variables. If we go back to our data dictionary, notice there were 17 variables. And if we look at the description of the data set, notice it tells me it includes 103 patients, or I could come down here and see 103 subjects, 17 variables. So that matches what I expect for this data set. Now to view the data set, there's two different ways we could do that. We could use the view function, and notice that will pull up the data set here. Or you can double click on the name of the data set here and it will also pull it up. So either way, we can look at our data set. Now one thing that I want you to notice, if you scroll through the data set, let's look at age. So as we scroll through the data set, we can see that there are no missing values. We could look at the same thing for BMI, but notice for BMI there are a couple missing data points. So keep that in mind as we look further in the future. Alright, so let's go back to our script. So the first thing we're going to do is we're going to explore our data set, and what we want to do is figure out the number of subjects in each of the groups. To do this, we can use what is called the table function. So here I'm going to call the table function, and functions are always written so that there's an open and closed parentheses after them. So if I write this like this is just the table function. So I need to tell R what I want to apply the table function to. Well, since I want to learn the number of subjects in each group, what I'm going to do is apply the table function to the variable group. So here, what I'm doing is I'm calling the data set, then I'm having $sign and the name group. What this is saying is I want R to pull the group variable from this data set. So now running this all together, here's what it produces. Now at first this doesn't look that informative, but we need to remember that group has been coded as a 1 or a 2. So if we go to our data set, or our data dictionary, we see that 1 is for the mixture group and 2 is for the sequential group. So I can see that 52 subjects received mixture and 51 received sequential. Next, I might want to look at gender by group. So this time I'm going to use the table function again, except I'm going to give it 2 different variables. So I'm giving it the group variable, just like I did earlier, comma, and then the gender variable. So we can run this. And here's our new table. But we need to remember that our variables have been coded. So notice here on the sides, we've got the 2 possible groups. We've got group 1 and group 2, or mixture, sequential. And along the top, we have 0, 1. So again, going back to our data dictionary, we can see that 1 is male and 0 are female. So what this first row is telling us is in the mixture group, there were 33 females and 19 males. In the sequential group, there were 24 females and 27 males. So what we might want to include in our tables that you have in that Word document is the percentage of males in each of the groups. So remember that in the mixture group, we already saw there were 52 total participants and there were 19 males. So we can take 19 divided by 52, run this, and we can see there are about 36.5% of group 1 are male. We could do the same thing for the sequential group. The sequential group had 51 total participants and then had 27 males. So again, running this, we can see that about 53% of this group are male. So there's a good amount of difference in the gender for these 2 different groups. So when analyzing the data, this might be something that a researcher would want to account for. So next, if you'll notice in that table that we're going to fill out, we want to look at age, BMI, and opioid consumption. So to do this, what we're going to start out by doing is we're going to create 2 new data sets, one for each of the groups. So first, we're going to look at the mixture group. So to do this, what I'm going to do is let's focus on just this piece of code right here and see what this does. So I'm just going to copy it right here so we can focus on it. Notice here, I'm calling the name of my data set, and I'm following that with a set of square brackets. So I have a square bracket here and a square bracket here. So in other words, we have this. So anytime we have a data set and we follow it with square brackets, what we can tell R is which columns and which rows we want. And we separate them with a comma. So anything before the comma is going to correspond to the rows, anything after is the columns. So for example, if I ask for the data set with 1 comma, nothing between it, this is going to give me the first row of my data set. So that's the first row of the data set. If I ask for first row, first column, it will give me that element that's in the first row, first column. Okay. So now, notice in the next line down, before the comma, I've placed this. What this is saying is I want all of the rows for which the group variable is equal to 1. So why would I want this? Remember that group 1 is the mixture group. So by having this line of code, what I'm telling R to do is to go look at this data set and find all the rows for which the group variable in this data set is equal to 1. In other words, find all of the mixture data. So piecing it all together, we have this line right here. And so notice I'm setting that equal to mixture group. So if we run this, notice a new data set appears up here in the right. We can see that it has 52 observations of 17 variables. Well, remember, we already said there were 52 subjects in the mixture group. We can view this by clicking on it. And notice here, if we look in group, all the group is equal to 1 for this data set. We could also use the nRow function just to see how many rows are in this data set, and there's 52, which we would expect. Now this next line of code is going to do this exact same thing. The only difference is group is now equal to 2, so this will give us the sequential group. So notice up here I've got 3 different data sets. I have my original data set, I have a data set that just has the sequential group, and I have a data set that has the mixture group. So now we're going to go through and explore some of those other variables that we need to look at to create those tables. So the first one we're going to look at is BMI. I'm going to use the mean and the median function to explore BMI. Now the first thing I'm going to do is just look at all of the subjects and ignore which group they were in. So notice to calculate the mean, I'm going to call my data set $BMI. So what this is doing is this is calling the BMI variable, and it's going to calculate the mean. And now I've got this little bit of extra code here. So what I'd like to do is actually I'm going to delete that out, and I want to show you what happens if I don't include it. So I'm going to find the mean of BMI. Notice it came back as NA. So what happened here? Remember that BMI had some missing values that we saw later on. So by default, R is trying to calculate a mean, but there's missing values in there, so it doesn't know what to do. So that line of code, or that piece of code that I just deleted out, what that's telling R, this na.rm, is it's saying remove the missing data before you calculate the mean. And since BMI has missing data, we need to incorporate that. So we can run this, and we get mean and median for all of the subjects. Now I included this in here for illustration, just so you could see how to do this for the full data set, but you don't actually need this information for your table. What you need for your table is the mean and median BMI for our mixture and sequential group. So remember, we already subsetted the data, so we've got a mixture group data set and a sequential group data set. So here, to find the mixture group BMI, we called mixture group $BMI. I'm going to have the na.rm equals true, and then the mean function. So I'm going to run this for both the mean and the median, and notice I get mean and median for my mixture group. I can do the exact same thing for the sequential group. Alright, so now I've got mean and median for the sequential group. And we can see that the mean and the median for the sequential and the mixture group are very close in terms of BMI. Now to fill out the table, you're going to want to do this for the 3 different opioid drugs as well as age. So to do that, all you'll need to do is copy these 4 lines of code, paste them, and then notice for these we're interested in age, not BMI. So what you'll want to do is you could click on any of these data sets because they all have the same variables. For this one, notice that age has a lowercase a. Remember, R is case sensitive. So here we want to explore age. So I'm just going to change all the ages, or probably all the BMIs to age, and then we'll be able to calculate the mean and the median of age for our 2 different groups. And of course I want to go in and change my comments because I'm no longer looking at BMI. And then last, you might wonder about this na.rm equals true. Remember that age didn't have any missing values. Well, it doesn't hurt to keep that in there. If there are no missing values, R is just going to say there's no missing values, I'm going to go on my way. So it's a good idea to always include that piece, so that way the code will run whether or not there are missing values. Now later on in the course, when we really start analyzing data more, we'll talk about the importance of documenting the missing values if there are any, and documenting how many missing values there are. For right now, we're going to ignore that, but know in the future that is something that we're going to want to account for and make note of. So then to finish the table, again, you'll just keep on doing that same process, but you'll do it for these 3 variables instead of the age and the BMI. So as always, if you have any questions about this or you need help, please let me know.